Bismillahirrahmanirrahim. As suggested previously, that we're going to learn three ways of writing quadratic functions. If you recall, the first one was the vertex form, f of x equals a times the quantity x minus vx squared plus vy. The second that we shall learn is f of x equals ax squared plus bx plus c. And finally, the third version, f of x is equal to a times x minus s1 times the quantity x minus s2. Now this first one is the vertex form, and today I just want to do another example in this form. The second form, as you know, this is the standard form. And finally, the third one again was the x-intercept form. Okay, so the question before us is this one. Our objective is to graph it. As you recall, the vertex form is so named because the vertex, so to speak, is given in the function. If I were to write the vertex form again, f of x is equal to a times the quantity x minus vx squared plus vy. In the nucleus of the parentheses, so to speak, right there was our vx. And outside over here was the vy. In this case, the vertex is going to be 1 and 2. So let's graph this. 1 and 2. So this is 1 and 2 right here. So that's our vertex with the ordered pair 1, 2. As you recall, as suggested, as soon as you have the vertex plotted on the graph, it is best to just draw the axis of symmetry because it's so useful in completing the graph. So here's our axis of symmetry. And the line is a dotted line to suggest that it's not part of the graph. That is, it's not part of the function. It's just there to assist us in graphing the function. Okay, so we have our vertex and we have our axis of symmetry. The next thing that we look at, as you know, is this A over here. Because that A right there determines if the graph is going to open upward or downward like this, if it's going to be a U or an N like this. In this case, because it is negative, the graph will open downward. That is, this graph will look kind of like this. Now, all we have to do is generate some points over here and some points over here. But rather, I'm going to generate some points over here and just reflect them across from the axis of symmetry to get the corresponding points on the other side. So basically, we only have to get some points on the side. Okay, so let's make a table. Now, you can technically pick any point over here, any point to the right of the axis of symmetry, that is. So you can pick any points here. You can pick 2, you can pick 3, you can pick 4, you can pick 5, you can pick 6, etc. But sometimes a little foresight is very helpful here because there's a fraction, and certain x values will be more user-friendly than others. I'll show you what I mean. So if you were to pick 2, then y would be equal to this, negative 1/2 times the quantity 2 minus 1 squared plus 2. I simply substitute the 2 in place of x. So this is negative 1/2. 2 minus 1 is 1, and the squared plus 2. 1 squared is 1, so this is just negative 1/2 plus 2. And this is 3/2 like this, or 1.5. Now, it's a fraction, but we can handle it, so it's 3 over 2, or 1.5. So that's what I mean, see? If you could foresee that if you put a 2 in over here, you're going to get 1/2, and it's going to be a fraction, you could avoid that. But in the end, it's not so bad. On the other hand, if you put a 3 in there, see, you get y equals negative 1/2 times 3 minus 1 squared plus 2. So this is negative 1/2 times 3 minus 1 is 2 squared plus 2. So this is negative 1/2 times 4 plus 2. 2 goes in there one time, that's 2. That's negative 2, and that is 0. And that's quite convenient right there. In the same way, if you pick 4 over here, you get 4 minus 1, that's 3, and that's not going to be a friendly number. But if you pick a 5 over here, 5 minus 1, that's 4. 4 can be divided by this 2. So it looks like odd numbers here are going to do pretty good. So let's get another point here. So y equals negative 1/2 times 5 minus 1, because I skipped this 4, because that's going to give us a fraction, squared plus 2. So that's negative 1/2. That's 4 squared is 16. 5 minus 1 is 4, and that's squared 16 plus 2. So that goes in there 8 times, and that is negative 8 plus 2, and that is negative 6. So I got negative 6. So now I have 3 points. So now I have this point, and this point. Now, you can reflect this over here. Now, you have to be very, very careful to reflect this across the axis of symmetry. In other words, the graph of this parabola is symmetrical about the axis of symmetry. It's not symmetrical about the y-axis. So a common mistake, and I've been guilty of this myself, is to accidentally reflect this point across the y-axis over here and bring it kind of like over here. And that would be incorrect. And this point, which is like 3, 0, to like negative 3, 0, and that would be incorrect because you're not reflecting about here, you're reflecting about right here. Okay, so let's do it carefully. So the thing to do is to count the boxes. So this is one box removed from axis of symmetry. So you go this way, one box removed from the axis of symmetry. So this point would be like over there. And this point over here, which is 3, 0, is 2 boxes removed from the axis of symmetry. So it's going to be 2 boxes removed this way over here from the axis of symmetry. So this point will reflect right over there at negative 1 and 0. Now the last one here, now that one's like 4 boxes removed. See, 1, 2, 3, 4 boxes removed. So you go 1, 2, 3, 4 boxes this way. And that's right there. That's negative 3 and negative 6. Okay, so now we have plenty of points. That's 1 over here, and 1 over here. All we got to do now is connect the dots. And there we have our graph. This function here is y is equal to negative 1/2 times x minus 1 squared plus 2. Before I finish, I just want to caution you about 2 things. As soon as you put the vertex on the graph, draw the axis of symmetry. That will help you a lot. The second thing is be very, very, very careful when you're transferring these points across from the axis of symmetry. Just count the number of boxes here and count the number of boxes here so you don't accidentally reflect in about the y-axis. Then you get an extra box over here, and this point would be like over here or something. So make sure you reflect the parabola about the axis of symmetry, because parabolas are symmetrical about their axis of symmetry. Until next time, As-salatu wassalamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.